Hey Natalie, what are we working on?
Cabinets.
Oh yeah, how's that going?
What season are we in?
Well, technically it's the start of fall. April, May, June, you know what? That's not important. The part that is important is that we're in the final push and we're gonna get this project done if it kills me. So the last big piece is we gotta make the cabinet doors. The cabinets themselves have been done since like, I don't know, April. But these pieces are all cut. I had to make these panels, glue them up, sand them. Sanding has got to be one of the least exciting things you can possibly do in woodworking. That's where we're at. So we need to finish this, and then we need to finish the computer electronics part of the lighting and put it together. Sound like a plan?
Yeah.
You guys ready to finish this?
Yeah.
All right, hands in. Okay, on three, we finish this. Ready? 1, 2, 3. Finish the cabinets. All right, you go that way. Go this way. All right, here's the idea on how this works. These are raised panel door bits. They're gonna cut a profile into these pieces.
Okay.
So the way this works is this is the side of the door. This would be the top and the bottom of the door. And different bits cut different profiles. But in the end, what'll happen is there'll be grooves and these will slide into each other and create a nice tight joint. And then we take the big panel and we'll use this big one to cut the sides so it fits into the groove as well and creates a finished panel.
Okay. Fit.
This is a router.
But what for what? Don't touch it.
It takes the bit and it spins it at very high speed. And then I put this whole thing inside this table, and then I can set everything and be very precise.
I've been pooping on that big hole will fall down.
It's not going to fall down because there's a piece in the bottom that holds it.
Oh.
Okay, and then this is going to spin at really high speed, and then I'm going to get everything just so, and I'm going to send the wood through the bit, and it's going to cut the profile.
Okay, can I do that too?
Sure, why not?
Once I did it. I have a one, Gaggy. Once I put this on.
So just swapped out the bits here. This one will cut the mirror image of this profile, and it will do that on the side, so right here. And then that's how the ends of these pieces would then fit on the inside of these pieces. This is not a real piece, this is a piece of scrap. So I just cut this test piece. This is the inside cut versus the outside cut that I did on the last pass. And pretend this isn't here, this is a test piece. So I take a real piece, and then they should fit together. Ta-da! Alright, so now we take these pieces and they fit like so.
Look, I can't TV. Ah.
See? We just made the outside. Now we gotta do the inside. Yeah.
Yeah.
Ta-da! What do you think?
It is perfect. Daddy has been making this. Thank you guys. Since it was summer.
Hey. All that's important is that we're finishing it now. Hey Natalie.
Yeah.
Do you remember how we started making this video in fall?
Yeah.
Yeah. Merry Christmas. Alright, so a couple last minute electrical troubleshooting items. I made a whole video on this last year, but just to quickly recap, what this is a sunrise sunset calculator that'll turn the lights in the cabinets on or off. So they'll kick on at night, they'll go till the morning and then kick back off. So the way that this works is there's an Arduino that has a real-time clock in it. The internal code calculates, depending on latitude, longitude, and time, if it's before or after sunrise or sunset, and then the code will turn this relay on or off, which allows the lights to turn on or off. So there's two cabinets, which means there's two controllers, and the way to get these two synchronized is to let them talk over RF. So that's the last little thing I've been troubleshooting. While troubleshooting the RF module, I hooked it up to the oscilloscope here, getting an awful lot of noise. This is the signal out of the master controller, and this is the signal into the slave controller coming to and from the RF modules. And the signal coming from the receiver is very, very noisy, so I had a problem with the baud rate. It was too high, so the noise was causing issues, so I dropped that, which cleaned it up. And another question I had was whether or not the master controller could tell the slave controller to turn on quickly enough, but we're all zoomed in here, and you can see the difference between the waveforms is in the order of I don't know, what is this, 40 microseconds, so should be quick enough. Over to the computer. In the end, this little guy right here ended up being the problem. I dropped it from 2400 baud to 1200, fixed the problem. And for lots of hardware, software debugging, that all comes down to the one magic setting. This is the live feed coming from the controller. It has the current time on the real-time clock. It's calculating sunset and sunrise time. So sunset's 5:15. Sunrise, it's calculating at 7:51. And this is important to remember, this is a calculation. It's based on an algorithm that's programmed onto the chip. But if we compare that against the actual time, we can see that 7:53 versus 7:51, this is 5:18 versus 5:15. Pretty darn close. Not so bad if I'd say myself. Hey Natalie.
What?
You know what time it is?
Sunset.
Oh yeah. You know it.